We are about to take the next big step here and create our PCB from our finished footprinted schematic. PCB doesn't exist yet. Do we want to create it? Yes. And it opens up a great big window with nothing. Update PCB from schematic. We have an error. Multiple items J3. Let's see, what's that about? 2, 3, 4, 5. 3. 3. We are reusing the same number twice for some reason, so we're going to fix that. J1. All right. Let's try it again. No warnings, no errors. Update the PCB. And we find we've got a whole mess of stuff. Now, this red outline is a workspace, so we're going to try to keep things in the middle for the moment. But we're just going to have to set this down somewhere to start with by just bravely clicking in the middle of the screen. Let's zoom in and take a look. Look at all this stuff that is all wired up. And this is going to be the focus of our next considerable bit of work, is turning this mess into something that makes a bit more sense. Everything's wired up and presumably would function once we got the routing of the wires set up. But it doesn't have an arrangement that we like at all. We would like our sequencer to be arranged to match the Eurorack format with all of the pots in a nice line, and all the LEDs in a nice line, and all the outputs on one side, and our connector in a standard location. So we do have some work to do, and that means we're going to have to start by defining the shape of the final board. Review the standard for Eurorack modules. Go on to Wikipedia here. Eurorack gives a little bit of history. Specified in 1996, originally by Duffer. And the physical specifications are heights in units of U, or a rack unit. 3U is the Eurorack standard, and that is 133.4 millimeters, 5.25 inches high. And the width should be some multiple of HP, or horizontal pitch, where an HP is 5.08 millimeters, or 0.2 inches. Also gives here the electrical standard, by now which we're familiar with the 10-pin electrical standard, doing plus minus 12 as it says, dual rail. It's plus minus 12, and then ground in the middle with audio signals 10 volts peak to peak max between plus and minus 5 volts, and control voltages usually 5 volts peak to peak at volt per octave scale, and with trigger, gate, and clock signals digital 0 to 5 volts. The original standard is still available online. So this is from the A100 rack from DePaul. You can see it actually was built to mount into a standard 19-inch rack you would find in laboratories or studios. Here's what one looks like. You can see the power bus in the back with the flat ribbon cable plugs with IDC connectors, and here's what we're after, which is the size. And so for Euro rack modules, they'll have the holes in a very particular location, and the spacing should be some multiple of 5.08 millimeters. The size of the holes for mounting, etc., are given here. In particular, if we wanted to try to stay to 6U, that would be 30 millimeters across, or 6 HP, that'd be 30 millimeters across, or 8 HP would be 40.3 millimeters across. This seems like a reasonable width. That'd be 4 centimeters for our sequencer. Here's just another image, more modern. Shows a 3U panel. So the height is the standard Eurorack height, and it says that the PCB here in green should be 110 millimeters high, 128 millimeters from the top to bottom of the rails, to give a total with lip size of 133.35 millimeters for 3U. Note there is a 1U standard that's very common, is quite compatible with the Eurorack in every other way. Allows you to fit 3 modules in one larger panel. We won't be using that in this class. But that's what we need to do, is have a board that's 110 millimeters tall and say a little under 40 millimeters wide, so it can fit in a 8 HP slot. As we're going along, it's a good idea to refer to the KiCad tutorial for version 5.1. We're going to be hopping right into board outlines here. Hopefully you've already gone through the entire tutorial before you attempt doing something as complex as actual sequencer board layout. So to do the edge cuts, that's the edge of the PCB, make sure that edge cuts here is selected. Use the polygon tool. First though, we're going to make sure that we have a grid that does us some good, so I'm putting on a 1 millimeter grid. Here you can see the grid. And we're going to find some place to rename our origin up in this corner. Numbers increase going across the top, and then increase as you go down. You can see those numbers down here. Where I have this origin is set for the grid here. So just choose a location. That's our origin point, And so as my cursor hovers close to that origin point, no, that's good. Let's make a polygon. Click once. And then double click at the end. Looks too ambitious, I would say. Let's actually check what the dimensions are using the ruler. Okay, we're only 88 millimeters. We need to go down to 110. And then out to, say, 40 this way. $110. 40. If the start point in y is at 30, the end point in y needs to be 110 plus 30, which is 140. If the start point in x is 60, the end point is 60 because that's just across here. So go down there. duplicate. Check our dimensions again. Oh, looks like this one needs to move a bit. $30 millimeters. $110 millimeters. Looks like it won't all quite fit, right? I think we're going to need a little more space. Let's check that standard. Very nice. We'll see if we can fit it in here without getting too crazy. Oops. $40 millimeter. All right. The rat's nest is going to be our next target after we get pieces onto our actual cutout. So we're going to begin moving pieces onto the board. I'm going to start with the potentiometers because that's the part where we really want to have a very particular layout. So as I grab a piece using the selection tool, the rat's nest should come along for the ride. There's 17, so he'll actually go close to the bottom. And that's 10, so he goes up towards the top. Now sometimes it's easier for this just simply not to view the rat's nest. I have a grid that's set to 1 millimeter. I find that that's reasonable to get the spacing about correct. Looks like we'll almost fit. Alright, not quite. We need just a little more space in here. Now we can make our sides a little bit bigger. You'll notice the VCO goes longer than 110. As long as we're under 113 or 114, usually fine. Looks pretty good. All our pots 10, 11, 12, 13, 14, 15, 16, 17 all in a row. We should be able to turn our rat's nest back on. What a mess, we'll have to clean up later. Let's get the LEDs and resistors in close proximity to their respective pots before we worry too much about things. So here's a LED, and that looks like number 16. So diode, here's an LED. Oops. Something like this happens, you've moved the label by mistake, just undo. I'm going to pause the video and let you line these up on your own. I'll show you my final parts configuration in a moment. So I finished laying out the pots, the 10 series and 20 series diodes. I'm sorry, the 20 and 30 series diodes and the resistors also. I chose to put all the pots in a line, and so all the components are connected directly to the pots, are next to them, and I've laid them out so they're all in equal groups. I'll turn off the rat's nest here so you can see the details of the layout. And you can choose other configurations. I did this one because with the rat's nest on, it minimizes the crossing back and forth. Right? And so there's really now only a few wires laying the board. And once you've played with a rat's nest for something that's complicated, you'll quickly appreciate that I had to spend some time figuring out exactly the configuration of components that I wanted to do. I included rotating them, using the R button, moving them around, etc. And then repeating it up and down the board. And taking a look, things look fairly even. I think I still need to bump this one pot up a little bit. There we go. Looking fairly good. So I try to strive for a even arrangement, and that minimizes the rat's nest. To give you a quick example, turn a rat's nest on. Were I to rotate this diode, it looks a little bit cleaner. Alright, so other than that little example there, I have everything in the same orientation. Stuff is lined up looking pretty nice. And it's ready to place some of the other components, figure out where they go. Now, since this is going to be turned into a real board with a faceplate, I have to remember that I will be mounting it using the 3.5 millimeter jacks. So those need to be sort of spread out across this side of the board, so they'll be attached to the top and bottom at least. Don't want to just have them all in one corner. The other thing is I might end up putting some holes in the board to make sure that there is space for mounting it with some standoffs perhaps. And so for that reason I'm going to actually, I think, slide all these LEDs over a bit so I have room for some mounting holes potentially. Let's line things up a little bit better. I should have room to the left of the LEDs for mounting holes. And I might have to play with this a little bit more. Again, if you're not snapping to the grid nicely, you can change that grid separation up here. All right, so let's think about placing some of the other parts. That's J3 and J2. So those are the outputs, one for the CV and one for the trigger. I think it makes sense to put the input more up at the top. and 3 and 2 perhaps at the bottom. Try to keep them like lined up. Hopefully find space for everything else, which has to include the power connector, as well as my pins here. It definitely looks like I am going to be running out of space on this board. That is not necessarily a problem. But I'm going to need some more room. So before getting into this anymore, it's time again to add a little more space. And so I'm going to pause my video while I clean up some of my messes and come back in a moment. Alright, so I finished arranging all of my parts on the PCB. One useful trick is to use the cursor tool that changes from just a crosshair to actually lines running all the way vertically and horizontally across the screen. I have chosen my components to minimize the mess of rat's nest, which will make it easier to do the traces, which will be the next step, which we start in the next set of videos. Well, I guess first we have to probably fix up these pots a little bit, footprints, but would be normally without doing that the next step. So you want to have nice clean rat's nest lines and not making too huge a mess, because everywhere there's a white wire, there eventually needs to be a physical wire routed in between those points. So you've done a good job of minimizing the rat's nest mess. One thing left to do is let's look at the 3D view. It's under View, 3D. And it looks like a beautiful artistic job. I've tried to do my best to, keep things neat and lined up and hopefully easy to search through and organize. Nothing looks too terrible, but I have a couple things left to show you. First of all, I should note that I've pushed the headers 2.5 millimeters apart. That means that they are on essentially a breadboard pattern, which is a convenient and standard size to use for things. 0.1 inches is a breadboard, or 2.54 millimeters. And I want to take care of moving this footprint. So if you're calling a VCO, I had the footprint on the wrong side, and that led to a lot of confusion. So let's flip that around. You do that by pressing F for flip. And now you can see the outline appears in a different color. And we'll rotate it to follow our convention view so far, putting the notch on the outside. And when we view it in a 3D viewer now, we see that the footprint is on the reverse side. Now we can check the electrical polarities right. Remember that delta means the -12. And we'll go back and view our wires in a moment to make sure that -12 goes where it's supposed to. But I'm pretty happy with this. Looks pretty nice. Much more aesthetically pleasing a job than I did on the VCO. And there's just a little space on the board where I can do some writing up above and below these headers. I can't really put anything component-wise here because the header shroud will go on this side, so it'd be hard to solder components that went through. So that is otherwise wasted space, so that's a good place to identify the board. And I've got a little tiny extra space down here I could potentially work with as well. And I still need to attend to labels a little bit as well, so just looking around. Couple of my labels are now off the board. And some of the pot labels are a little bit unreadable, so I might want to just shift those down and outside. I might also want to change up on these upper diodes some of the labels so that was more easy to see. Might want to possibly label this trigger LED actually on the board, perhaps even. Looks like in general I can read all my other component numbers, IC2, IC1 looks like it overlaps with that capacitor there. So I got a little bit of labeling cleanup to do. And that's actually all fairly straightforward. So grab that capacitor reference. Just maybe move it to the side of the capacitor. These diode references, I gotta move him off. That looks pretty good. And so, you know, I'll spend a little bit of time just making sure that the board is readable, which makes it easier, of course, to assemble. Especially if it happens to be assembled by the person who didn't design it. Oops. So do something about these lower diode and LED labels. That resistor label isn't very good. So a little bit of cleanup still remains. Alright, I think I finished up all my cleanup to the liking. One last look at the 3D view. Notice the writing that shows up is the front silk screen on the front or the back silk screen on the rear. The other reference values are not set to display. And I'll be able to see the value of each component when I place it in, with the exception of the LEDs, which are relatively obvious, I feel. And so let's get some text on it. Go and grab the text icon, make sure that the front silk screen is selected. Currently appearing in this darkish green color. And click approximately where we would like to write. Let's make it italics. So you can play around with that to your liking. Then I'll stick some name and acknowledgments, I guess, down here. Can't line things up quite the way I want them. There we go. Next on to footprints. Pad properties, hole size in X, hole size in Y. This must be the Y because it's bigger. That'll almost certainly fit. Looking at my measurements. Don't really want to make it bigger this direction because we're already pretty cramped for space. But it looks like we can continue to increase it here. So you go into 4. And looks pretty good. So 4 and 2.5, and we're just gonna go through and fix those up. So that pad is bigger now. And we're just gonna run through and fix them all.